If you've ever played 20 questions, you know that the answer to true-false questions can really say a lot. And in fact, in computer programs, true-false questions turn out to be fundamental. In this video, what I want to do is talk about a new kind of value called a Boolean that's going to represent the answer to true-false questions. I'm also going to talk about a number of primitive true-false questions and a new expression in Racket called if that's going to let us make our programs produce different values depending on the answer to true-false questions. Boolean values are going to represent the answer to true-false questions. So you shouldn't be surprised to find that there's two Boolean values. And in the beginning student language, we write them this way. True is the value that represents the true answer to a true-false question, and false is the value that represents a false answer. And since they're values, if we run them, if we evaluate them, we get the value themselves. Okay, let me comment those out. That's how we're going to represent the answer. What are the questions? Well, let me just set myself up here a bit. I'll give myself two constants, width and height, and I'll just make them both be 100. Okay, so here's a true-false question. There's a primitive called greater than, and if we say greater than width, height, and evaluate that, run that, we get false because width is 100, height is 100, and 100 isn't greater than 100. On the other hand, here's another primitive, greater than or equal width, height, and if we run that now, we get false for the first one and true for the second one because 100 is greater than or equal to 100. These kinds of primitives that produce a true-false value are often called predicates. So we would say that greater than is a predicate and greater than or equal to is a predicate. And there's lots of others. Okay. You could say equals 1, 2, or equals 1, 1. Let me just comment these two out so they don't confuse us. Or greater than 3, 9, and we'll run that, and equals 1, 2 is giving us false, equals 1, 1 is giving us true, and greater than 3, 9 is giving us false. And there's lots of others, and I'll remind you that the 1x lecture video will show you how to discover more of them. Let me just show you a couple more. I'll comment this out now so it doesn't confuse us. There's some that operate on strings. So for example, you can say string equals question mark foo bar, and that's false because those two strings are not equal. What if I want to ask questions about images? So let's see, suppose I want to have two images like this. I1 is a rectangle that's 10 by 20, and it's solid, and it's red, and I2 is a rectangle, and it's 20 by 10, and it's solid, and it's blue. Suppose I want to know which image is thinner. I could say less than image width I1, image width I2, and I can run that. Oh, let's see, rectangle, this function is not defined. Oh, this is the usual mistake where I wanted to use image functions and I forgot to put a require. I'll just go put require to http/image. And now if I run this, I'm getting true, meaning that the width of I1, which is 10, is less than the width of I2, which is 20. Okay, so that's Boolean values, true and false, and a number of predicates that are questions that produce true-false answers. Now I want to talk about if expressions, which are going to let us have our program produce different results depending on the answer to true-false questions, depending on the result produced by a predicate. If expressions are simple to form, it's open paren, if, and then three expressions and a closed paren. We call those three expressions the question, the true answer and the false answer. And one key thing is that the question expression has to produce a Boolean value. So the question expression usually calls a predicate of some form. Now let's look at an example. Going back to where we were, let me start by just deleting this expression here. And then we'll try to write an if expression that determines what the shape is of I1. So we'll say open paren if, and then let's say less than is the width of I1 less than the height of I1. And if that's true, that's the question. If the question is true, then here's the true answer. We're going to say that the image is tall if its width is less than its height. And in the false answer, we'll say that the image is wide. And if I run that now, there's two interesting things to see here. One is that the result was tall because sure enough, I1 is taller than it is wide. And the other interesting thing to see was that right here, this piece of code was highlighted in black. Depending on which version of Racket you're using, it might be highlighted in orange, but it's highlighted. We're going to talk a lot more about that later this week. But if I go ahead now and switch around, maybe I ask the question about I2 instead of I1. Well, I2's width is greater than its height, and in this case, if we evaluate the expression, it produces wide, and the true answer this time is highlighted in black. So you may be able to start to guess what that black highlighting means, but again, we'll talk about that later. So that's an example of an if expression. What we need to do now is look at the detailed rules for evaluating if expressions. What I'm going to do is first go ahead and put the evaluation rules for if here on the right. And then I'm going to change the example expression a little bit, just to make it a little bit richer so we'll understand the rules a bit better. I'll say that if the width is less than the height will produce the width, the true answer will be the width, and the false answer will be the height. Now let's try to step through that bit by bit. And I'll also use the Control-E or Command-E command to just make Racket hide the interaction area, so I've got a bit more room to work. So let's see, I've got an if expression, and the rule for evaluating an if expression is the first thing I have to do is evaluate the question expression. So there's the question expression. The question expression is a call to the primitive less than. So the first thing I have to do is reduce all of its operands to values. Let's see, the first operand isn't a value, it's an expression. In particular, it's a call to the primitive image width. And the first thing I have to do is reduce all of its operands to values. Gee, this first operand isn't a value, it's the name of a constant, so I have to produce a value for it. So the first evaluation step simply is going to reduce that expression, the constant name, to the corresponding value. In this case, what that does is that I2 becomes the actual image, the image value. Okay, so now let's see. If expression, reduce the question, reduce the operands to this less than, here's the first operand, that's image width of that. What happens here is that this whole thing, I'm just copying it and pasting it, this whole thing becomes, we just end up reducing this expression here this time, so that's going to become 20, the width of rectangle 2. The next step, well at this point I think you can see how this is going to work. Now we're basically reducing this operand to the less than. In the next step, the I2 becomes an image. And then in the step after that, that whole thing becomes 10. And I'll just put it on one line like this so we get a bit more room to work with. So remember what we did here is we had to evaluate the if expression. If wants to evaluate its question expression first. This was a call to a primitive in which both operands were calls to primitive. So there's a fair amount of evaluation work we have to do here before we've evaluated the question expression, and we still aren't even done. We still now have a call to a primitive. Both operands are values, so now we can actually call less than with the two values. Now less than 2010, well, 20 is not less than 10. So that's clearly going to be false. And now finally we've evaluated the question expression. We've evaluated the question expression. And now we go to the remaining rules of the if. Next rule says that if the question expression produces true, well, it hasn't. Here the question expression has produced false. So the next rule says if the question expression produces false, then what we're going to do is replace the entire if expression with the false answer. So there's the false answer. The entire if expression gets replaced with the false answer. Now we have a call to a primitive. First operand is not a value, so we need to evaluate it. So that has to get evaluated. Now all the operands to image height are values, so we can actually call image height, and we get 10. The whole thing evaluates to 10. And again, if we use that trick I showed you in the last video of running this now, we'll see a whole bunch of 10s, which tells us that we did all of our evaluation steps properly. So the key thing is the rule for if is first you evaluate the question, and then depending on the result of the question, you replace the entire if with either the true answer or the false answer, and then you just keep evaluating. What I want to do now is back up just a little bit. Let's go back to when we just had image 1 and image 2. And we know that if we want to find out whether image 1 has a height greater than image 2, we could say this. So that's comparing the height of I1 and the height of I2. And if we run that, we'll get true because 20 is bigger than 10. We could also, if we wanted to, compare the width of I1 and the width of I2 to see, in some sense, this first thing is saying, is I1 taller than I2? And this second one is saying, is I1 skinnier than I2? And that's true. Now, what if we wanted to know whether I1 was both taller and skinnier than I2, if it was both things together? Well, here's a new primitive called and. And is a special kind of expression like if. And the way and works is you can wrap open paren and around any number of other expressions that themselves are going to produce a Boolean value. And what and does is it evaluates the first one, and if that produces true, it keeps going. And if by the time it gets to the end, all of the expressions have produced true, then the whole and produces true. If, on the other hand, and gets to an expression that produces false, then it stops right away and produces false. So and does what's called short-circuiting. It doesn't keep evaluating if it comes to an expression that produces false. It only keeps going as long as the expressions are producing true. There's also a primitive or expression, and there's a primitive function called not. You can look both of those up in the help desk, and you can watch this week's 1i video to find out how to use the help desk.